guys, today we are going to be introducing the next unit and doing a little introduction of what a vector is. So that's kind of going to be what we're talking about for the next few weeks here. So let's define a vector first. So a vector is a quantity that has two things. It has something called a magnitude. The magnitude is the size or the length of the vector. And it also has direction. You can think of direction as the slope of the vector. So these two things, magnitude and direction, are what make a vector unique. Now, vectors are represented as a directed line segment. Now, what that means is it's just a line segment. If you look right here, you have PQ. But in PQ, there is a starting point and an ending point. It's very clearly going from P to Q. So P is the starting point, Q is the ending point. Now, the P is often called the initial point. Okay, or you can call it the tail. So P is the initial point or the starting point. Q is often called the terminal point. So you need to know those two things. The word terminal means where you end. So the terminal point is also sometimes called the tip. So it goes from tail to tip. Okay, just so you're familiar with those words if you happen to see them. All right. So when I write a vector, I use this symbol right here. So up here we have vector PQ. Well, often that's one way to write it. Now you can't really see this, but there is an arrow on there. So this is PQ with a little arrow on top. The other common way to write a vector is a bold-faced lowercase letter. So in bold, a P. So you can call it either one. You can call it vector P, or you can call it vector PQ with an arrow. All right? So like we said, these vectors, these things that have a direction and a magnitude, are the magnitude is just the length of the vector. It's how long it is from P to Q. So if you're ever asked to find the magnitude of a vector, all you have to use is the distance formula from geometry. So if you don't remember that, or maybe if you learned it a different way, okay, this is it. So this magnitude is symbolized by two lines on either side of the vector. So this means the magnitude of vector v equals, and then let's write this down. So it's going to be x2 minus x1 squared plus y2 minus y1 squared. That is just the distance formula, except for instead of d over here, we're writing magnitude of v. You can use that to find the magnitude of any vector. So let's do a couple examples. So AB, with A is 8, negative 4, and B is negative 7, negative 2. So again, these are just 2 points on the coordinate plane, and if you want to find the magnitude, all you're doing is find the length between these 2 points using that formula. So the magnitude of AB is square root, and then we just need to fill in this formula. So x2 minus x1. Well, x2 is negative 7, x1 is 8, and then y2 minus y1 is negative 2 minus negative 4, which again, remember, you can change that to a plus if you want. So all you're going to be asked to do is just figure out, okay, so what are these things underneath here? Well, negative 7 minus 8 is negative 15 squared. So what is 15 squared? $225 plus negative 2 plus 4 is 2 squared plus 4, which ends up equaling square root of 229. So that is the magnitude. Now, we may be able to reduce that, to break this down a little bit. So let's see. So that's 229. What are some perfect squares that might go into it? Let's try 81. No. Let's try 64. No. Try 49. So it's not looking like a lot of the big ones are going to be working here. Let's try 9. No. 4 is not going to work because it's even. 25 is not going to work. This may be as simple as this gets. If you can find one, great, let me know. Okay, so simplest form, there you go. All right, that's all we're doing for this. So remember, magnitude is just how long is the line. All right, so let's try this one. The magnitude of RS equals x2 minus x1, 5 minus negative 3, and then 6 minus 10. So this is going to be square root of 64 plus 16, and that's square root of 80. Now this one will break up quite nicely. So see if you can do that. How does square root of 80 break down? Well, what's the perfect square that goes into 80? 16 and 5, right? You could use 4, but 16 is the biggest one. So it's going to be 4 radical 5. There's the length. Okay? PQ? Same idea. If you want to pause it and try this one on your own and then check your answer, that's probably a good idea. All I'm doing is copying down x2 minus x1, y2 minus y1. This is 100 plus 225, negative 9 minus 6, negative 15 squared is 225. Square root of 325. And this one will break down nicely. So it's probably going to be 25, right? So 325 divided by 25 is 13. So it'll be 5 radical 13. There's the magnitude of that one. I know I did it quick, but I recommend you pause these and try them first. Do the same thing with number 4. So EF x2 minus x1 is negative 6 minus negative 1. Y2 minus y1 is negative 7 minus negative 5, which is 25 plus 4, which is square root of 29, which does not break down anymore. Now, I hope that I didn't make any mistakes here. If I did, please call me out. Let me know. Go ahead, try these on your own. And I will be posting a couple problems after the second part of these notes for you to do and turn in. So just make sure you're sticking with me here. And the last thing, just a zero vector, it's pretty, it's right in the name, but a zero vector is a vector with, you can hear my daughter in the background, with a magnitude of 0. Okay, and we're going to get into why that's important soon. All right, thank you very much. Bye-bye.